All right, so this problem says to solve the triangle if possible. I wonder what that means. I guess it's, wait, there could be no solution. But we'll see. This one has a solution. But it says to round angles and side lengths to the nearest tenth when necessary. And actually, it says to solve this triangle, it already has all the side lengths. All we need to do is find all three angles. We need angle A, we need angle B, and we need angle C. So when we solve this, we're actually finding all the angles. That's all we're really doing. So let's see here. I notice we know all the sides. What we don't have is we don't have a complete pair. Like we don't have side C and angle C as a complete pair. We don't have side A or angle A as a complete pair. I mean, we have side A, but we don't have angle A, so it's not a complete pair. And then angle B with side B is not a complete pair. We don't have any complete pair. So we can't use the law of sines because you need a complete pair to do that. So we're going to have to use the law of cosines. So law of cosines is c squared equals a squared plus b squared minus 2ab cosine of angle C. And so that's the one we're going to use. Since I know all the sides, let me fill it in. I'm going to pick this as actually being side C. I could use, the different forms of law of cosines, like I could switch the names of the sides, but I like the labeling that it has. This is the biggest side. I'll put it here for side C, and then side A, that's actually this one, if I go with the current naming convention. And then this is side B, and then minus 2, and then A again, which is 6, B again, which is 4. And then I got to use cosine of angle C, but remember, we don't know angle C. Let me make that obvious that it's angle C by doing a nice big capital. So this is what we need to crunch. We know 7 square. We know 6 square. We know 4 square minus, now I'm actually going to do this multiplication. That's 48 if you multiply 2 times 6 times 4. And then of course we're still multiplied with the cosine of angle C. The next bit of math I should do is actually we can add these two together, but we can't subtract because this is stuck together with multiplication. Don't mess that up. That's the common mistake. So what I'm going to do is I'm going to add that together. What is that, 52? As we keep just crunching this. Again, I can't do the subtraction because this is still stuck together with multiplication. So this is stuck together. What I can do is I can actually subtract both sides by 52 to get rid of that. Now, if I rewrite this, this equation, now I've got, what is that, negative 3? Yeah, it looks like it's negative 3. And then over here, I still have the negative 48 multiplied with the cosine of angle C. Now, we're trying to find the angle, and the angle is right in there. So what I need to do is get rid of some more stuff. Let's actually divide both sides by negative 48. That's because it's multiplied here with the cosine, with our angle that we're searching for. So these cancel. In fact, over here, the negatives cancel. And so what I've got now is 3 divided by 48, which I'm just going to leave as a fraction. I don't want to turn that into a crazy decimal. And then I have on the right side just the cosine of angle C. But my goal is to actually find angle C. I don't want the cosine of angle C. So what I really need to do is get rid of the cosine and leave the angle. The opposite of cosine is cosine inverse. So I'm actually going to do the cosine inverse of this side, and I'm going to do the cosine inverse of this side. That's of course going to cancel the cosine out. Let's get a little more room here. And so now I just solved for angle C. All I got to do is figure out what in the heck is the cosine inverse of 3 over 48. And of course we just use a calculator for that. If I'm in degrees and I type that in, I would actually get 86.4 degrees. And let's do degrees because this is just a regular old angle with some crazy answers, crazy numbers for the angle. So there we go. We solved for one of the angles. Okay, I'm going to go back and put that in my picture here. Let's scroll down a little bit and zoom out a little bit. Let's put that in here as 86.4. I rounded just to the 10th place, just like it told us to do. All right, now we still got to find the other angles. We could kind of use law of cosines again, or now that we have a complete pair, in fact, let me use the highlighter. We have a complete pair here, so we can use that to finish our other pairs. Now, if you remember from the law of sines, using the law of sines, if you use the law of sines to finish a law of cosines, we got to make sure we choose wisely. We actually have to choose the smaller of these. Okay, I actually think we'd be pretty safe because we already solved for the largest side and largest angle, but it's always safest to go with the smallest one next. Okay, so let's use actually the law of sines for this one. If you remember the law of sines, here I'll draw a little separation for that and scroll, give a little more space. Law of sines is going to look like this. It would be like the sine of well, since we're going to use the pair for C to solve for B. So I'll write it like this. It's the sine of C over C, that's angle C over side C, equals the sine of angle B over side B. And the reason we could do that is we know a complete pair. We know the sine of 86.4, that's degrees, over 7, that's our complete pair for side and angle C, has to actually equal the sine of angle B, which is what we need, divided by side B, which is 4. That's this blue pair over here. And we can actually solve for angle B now. I can actually just multiply both sides by 4. And then I've actually almost got angle B by itself already. That's pretty quick. Law of sines is actually very quick. And of course, I could crunch all this. I can get that as a decimal. Or if you wanted to, if you got a fancy way to type it in a calculator, you can actually just like leave it like this for right now, and we can type it in a calculator later. That's what, over 7. Oops, there's an equal sign here. So we've almost got angle B by itself. Now, what we need to do is get angle B by itself by getting rid of sine. How do we get rid of sine? We just do the sine inverse of both sides. So I got to sine inverse all of that, and then I got to sine inverse this. But really, all that happens when I sine inverse the right side is it makes the sine go away. So here's what we've got. We've got angle B is actually going to equal whatever we get when we type in a calculator of the sine inverse of all this craziness. And you literally could just type all that craziness carefully into a calculator. Or, oh, that's a 4 right there. The pen freaked out. Or if you just want to first type in this craziness inside here, which I've done, technically all that craziness is, let's see, I think it's about 0.57, if I have that written down right. And of course, really, once you finish just typing all of this in, looks like angle B is about 34.8 degrees. And so there we go, we found another angle. So we've almost finished solving this bad boy. Now we got 34.8 degrees. We only just need one more angle. And again, we could use law of cosines to find it, just like we found our first angle. We could use law of sines to find it, just like we did our second angle. However, the convenient thing is we already have 2 out of the 3 angles, and we know a triangle makes 180. So all we got to do is take away our current angles, like the first one that we found, and then subtract the second one that we found. And once we do that, we would get our third and final angle for A. So we just do all this subtraction. It looks like all we're left with is, what is that, 58.8 degrees. And that's, of course, about what angle A is. So now we found all the different angles. 58.8 degrees. We have now solved the triangle. We got all the sides and all the angles. Let's go to another situation here. All right, same kind of thing. It says solve the triangle, if possible. Maybe we can't solve it, but we can solve this one. It says round the angles and side lengths to the nearest tenth. Again, we actually already have all 3 sides of the triangle. All they just didn't do is they just didn't draw it for me. So let me just kind of draw. I'm just going to draw a random, this isn't drawn to scale. AB, actually AB looks like the longest, so maybe I should draw it down here. So that's, I'll call that A, I'll call that B. And then B to C, which this must be C, B to C is 15. And then A to C, this one is 13. So we got to solve it. Again, we're just solving for all the angles. Just like before, we have no complete pair. We don't know angle C to finish off side C. We don't know angle A to finish off side A. And we don't know angle B to finish off side B. We have no complete pair, so we can't use the law of sines. We're stuck using law of cosines again. So let me write it out again. It would be C squared equals A squared plus B squared minus 2AB and cosine of angle C. And let's just plug in the numbers that we got. We know this will be A, and that's 20 square. Across from, did I just say A? This will be C across from C. This will be A across from A. Sorry if I mixed up my letters there. B, side B is across from angle B. And then 2 times, let's see, we need A, which is 15 again. We need B, which is 13 again. And then times the cosine of angle C, which we do not know, and we're going to find it. So let's do all of this, crunching here, all the calculations using a calculator. That's what, 400. This is what, 225. And this is 13 times 13 is 169. And then all of this, multiplying those together, is 390. And then we still have to multiply with the cosine of angle C. Looks like we can add these two together. So let's leave this side alone and add those together. What does that make? 394 minus 390 times the cosine of angle C. And once again, we cannot do that subtraction here because this is all stuck together with multiplication. What we can do, though, is actually subtract 394 from both sides to consolidate all that over on the left side. So these cancel. And now we've got, what is that? That's just 6, right? 6 equals, and then we have the negative 390 multiplied with the cosine of angle C. And we've almost got angle C isolated. First, we got to get rid of this multiplication. So we're going to divide both sides by negative 390. Okay. And here's what we've got. We've got cosine of angle C on the left. No, that's the right. And on the left, we got negative 6 over 390. It's just a negative fraction. That negative doesn't cancel. Okay, we've almost got angle C by itself. All we need to do is get rid of the cosine, and to do that, we're going to do the cosine inverse of both sides. Cosine inverse of this side, and cosine inverse of this side. Sneak it in there. And so now we got angle C by itself, and it's going to equal the cosine inverse of negative 6 over 390. So I just got to crunch that on a calculator. Again, make sure we're in degrees. Let's do this in degrees. It's going to give us kind of a crazy answer. Actually, it looks like it's about 90.9 degrees. So we just found angle C. Maybe I'll put angle C right there, approximately. And so let's label that in here. That's about 90.9 degrees. All right. Now what? We got to find the other two angles. Again, we could redo this problem using the alternate form of the law of cosines to help us find like angle A, for instance, or angle B. But instead of doing that, because this is a lot of work, what I want to do is switch over and use the law of sines. Now that I have a complete pair for angle C and side C, I can use that to finish another pair. And again, the safest way to do this is to always pick the smallest side to find the smallest angle next. There's a reason for that, because the law of sines has an ambiguous case of the law of sines. You got to watch out for that. So to help avoid that, we're going to find the smallest one. So we already know the yellow pair. We know that the sine of angle C, 90.9 degrees, over side C, which is 20, has to equal, and we're going to finish the blue pair for angle B. So the sine of mystery angle B divided by 13 has to equal that. It's really quick to solve this one. We're just going to times both sides by 13. Let me scoot that over a little bit. There we go. And so now we've got, oh wait, that's gone. We've almost got angle B by itself. In fact, we could crunch this on a calculator, but again, I'm going to show you, you actually could just write this down for the moment. We'll grab the calculator in a second. We've almost got angle B by itself. All we got to do now is do the sine inverse of both sides. Sine inverse of this side, because we really want to get rid of this one, so we'll do the sine inverse of both sides. So we can get rid of that. Now we've got, what was that, angle B all by itself, and really it's just going to be this mess. If we could type this in the calculator, the sine inverse of all of that. 13 times the sine of 90.9 degrees all over 20. And of course, I actually already crunched all of this craziness. So it's actually the sine inverse of, what was that, about 0.65. You could type that in and double check, about. And of course, if we crunch the sine inverse of that, that would give us our actual angle. And I get about 40.5 degrees. So now we found our second angle. Let's put it into that picture. We got 40.5 degrees. And just like the other problem, I don't want to use the law of cosines to finish that. That's too much work over here for the first angle. I don't even want to use the law of sines. It didn't take that much work, but it would actually be easier just to go for it and find the third and final angle by subtracting from 180. Triangle makes 180, so let's get rid of the 90.9 that we already have. Let's also get rid of the 40.5 that we already have, and that would actually give me angle A. So A must be about, if I crunch that math and see what the remaining angle is, it's about 48.6 degrees. I'll put that into my triangle. It's about 48.6 degrees, and that's a 4 there. All right, so we found all the angles and we already had all the sides. We just solved the triangle.